This video is to go over dimensional analysis and using units to solve problems. So I'm going to do three examples. The first one is like what you're going to see in chapter one. These aren't really chemistry conversions that we're doing here, but you do them exactly the same way as you would a chemistry conversion. I'm going to do number 48. It's actually from chapter one, and some of the assigned problems are like this. So if you have trouble, take a look at how this problem's done. Also, I just wanted to repeat that the summer assignment, you should be doing your the problems that require dimensional analysis. You should be showing it just about exactly like how I'm showing them in this video. Um, there's one additional way that you may choose to do it, and that's with like these. I'll cover that when I get to it. So let's go ahead and get started on this problem. So I'm gonna do just A right here. So it says the speed of light in a vacuum is 2.998 times 10 to the eighth meters per second. Calculated speed in miles per hour. So my now I the way I teach this in general chem is I tell students to write the given number in unit. So it's 2.998 times 10 to the 8 meters per second. And then we're gonna list a conversion factor, and then the desired units. So first is to write the given, then the desired unit that we're trying to change it to, and then list the conversion factors. So I'm doing this only for instructional purposes, putting it in this chart. It's called the GCD table. You don't need to show the GCD table. What you do need to show is the entire solution to the problem with the units cross canceling, and I'll show you that in a second. So our desired unit is miles per hour. So we need a couple of conversion factors. So first off, we need to know how many. So we need to change this, the meter. We need to change that into miles. So we need the connection between a meter and a mile. What I always do is I ask how many of the smaller units are in one big unit. So what I'm going to write right here, you could do it the other way, but it gets a little weird. You're going to start to get these fractions, and it just gets kind of weird. So just to keep it consistent, I like to do it the same way every time. So 1 mile is how many meters. So you could just go to, you could open up your browser on your phone, okay, and then you just go, how many meters are in 1 mile? So I'm using the Google Assistant on my phone. So I get 1 mile is 1,609 meters. So I'll write mile, I'll abbreviate MI, meter, just M. Next, so that should take care of the top unit. Next, I need the connection between seconds and hours. You could do it in two steps, how many seconds are in a minute, and then how many minutes are in an hour. But you should find out that you just times 60 times 60. So in 1 hour, so again, take one of the bigger unit. 1 hour, there are how many seconds? 3,600 seconds, which is just 60 times 60. SEC. So now that I have the two connections, I have like the two bridges, my conversion factors, I'm ready to solve the problem. So here's the part where it's required that you show this step. So the GCD table, I'm doing that for instructional purposes. But here for your solution, this is what's required for all the chapter 1 problems and all the chapter 3 problems that you're doing a dimensional analysis. So we rewrite our given 2.998 times 10 to the eighth meters over seconds times, and then I draw a line. Okay, now what I want to do is I want to get miles up here. That's my strategy. That's the goal here, is to, instead of meters, I wanted to say miles up here. So that means I need to take the meter unit, which is right here, and I need to put that along with the number down here. Okay, and then the 1 mile part of it goes on top. So I'm going to write 1,609 meters, and then I'm going to write 1 mile on top. So the units tell you what to do. It's just like in algebra. If you have like 8x, okay, and then you multiply that uh by 1 over 4x, okay, the x's cancel, so you'll have like x over x, and so those actually just drop out. Okay, so it's exactly like that. So the meter and meter they cancel, and now I'll have miles. So if I stop the problem now, I'll have how many miles per second the speed of light is. But this says to go all the way to go to hours. So now I want to put seconds is down here, but I want to make it say hours on the bottom. So I need to put seconds on top right here. So I'm going to take this unit right here and I'm going to write it on top right here. So I'm going to write 3,600 seconds so that the seconds cancel with that seconds there. And then the 1 hour I'm going to put right here on the bottom. So I'll write 1 hour here on the bottom. Okay, and then now I have my the desired units. I have miles and I have hours. So now I just need to enter this into my calculator. Um, so I have a little tip for your calculator. I'm gonna go to I have this casting from my phone. So I'm gonna open up my calculator, and I like this where you go second you go F1. So I'm gonna hit the green key, this alpha, and then F1. And I really like this fraction right here. So I'm gonna take that. Okay, and then I'm gonna enter my number here. So the speed of light 2.998. And instead of hitting times 10, like times 10, and then caret and all that stuff, I really dislike entering that. It's too many keystrokes. So I'm gonna delete all that stuff, and I'm gonna use this E button right here. So it's second function and then E. So second function and then E, and then I just enter the exponent 8. And then in my problem, it was times 3. So I'm gonna enter all the stuff on the numerator, 3,600. And then I'm gonna scroll down to enter the stuff on the denominator, which was 1,609. Okay, I hit enter, and there's my answer. So that's 3, that's 6, 7, 8. So it's a big number because that's a speed of light. So that's how many miles per hour it's going. So 3, 6, 7, 8, 6.7. Now, as far as sig figs, let's take a look at our calculation here. So as far as sig figs, this number could be written to many, many sig figs, but the book, they gave us this many. They gave us 4. This is an inexact number because you're crossing over between English and metric system. If you're doing metric to metric, those are exact numbers, so those do not limit your sig figs. This one is not exact. In fact, uh, Google gave me, what did Google give me for that? A whole bunch of numbers. I cut it off after 4 just so it would match this number. So anyhow, our answer should be from our calculator 6.7. I should include 4 sig figs. This had 4 sig figs and this has 4. I I kept 4 here on purpose to make sure that my conversion factor did not limit the measured value. So this is usually the number in the problem they give you is what should limit your sig figs. So 6.708. I'm gonna cut it off at the 8 right here times 10. And what were my exponent here? 3, 6, 7, 8, 8 miles per hour. Okay, and then box your answer. So that's a non-chemistry example. So I'm going to go ahead and do a chemistry one. In the your turn at the end, I'm going to ask you to do B, C, and D. Okay, so on this one, I'm just going to do A and B here in the problem. So in part A, it says, what is the mass in grams of 1.23 moles of iron sulfate? So iron 3 sulfate, that would be Fe3 plus, and sulfate is one of the polyatomic ions you're supposed to have memorized, so it's SO4 2 minus. So when I write my formula, it's going to be Fe2 parentheses SO4 close parentheses 3. And that's important because I'm going to need to know the molar mass of this to do this problem. So I have 1.223 moles. I'm going to go ahead and do this one in a GCD table just to explain how. So obviously, do you multiply or do you divide by the molar mass? That's the question here. But that's actually the side question. Don't ask that question. Let the units decide what you're supposed to do. So I have 1.223 moles of Fe2SO4 3, and my desired is grams of Fe2SO4 3. So my molar mass is going to be the conversion factor. So anytime you get a molar mass, you go 1 mole of the substance, which is this, equals, I'm going to leave it blank for now, grams. So what I'm going to do is I'm going to go over to um, my molar mass calculator. So this is the one I prefer. It's on Android. I do not think it's on iOS. So it's just called molar mass. So um, if I go and I do a search for if I do a search for molar mass, then I'll find all these different choices. So this is the one I like. I think the one I used to use is on iOS. It's this one right here, CMM. You could find you could find whichever, but I've tested a lot of the ones on Android, and I found that some of them have errors. This one I really like because when you start typing in the substance, first of all, it allows you to type in parentheses. So I'm going to go Fe and then two. And the thing I love about this is it does. So I'm going to add in my parentheses SO4 and then 3. Usually it finds it automatically for you. As soon as you start typing it, it comes with like suggested results, and you don't have to type in the whole thing. This one, it didn't find it for me right away. So, anyway, it's a 399.91. Okay, so I'm gonna go back to my problem here, and it's 391 or 99.91 grams. So I don't I don't want you guys to show work for adding up the atoms. I think that's like rudimentary skill that everyone should know how to do already. Now, just a word of caution: if you don't know how to do that, you want to have the app on like quizzes and tests. So if you're not sure how to calculate a molar mass, then when you get to chapter 3, there's plenty of practice to do. But if you're fully confident in calculating a molar mass, which you should be if you signed up for AP Chem, then go ahead and download any one of those molar mass apps. And I showed you my preferred one that I like to use. So now we're ready to solve the problem. We have the connection between moles and grams. So I rewrite my given. So this is the part that's required, is the part that I'm showing right now. The GCD part is not required, but I like to show it in videos sometimes for teaching purposes. Because it really shows that the distinction between like which unit do you put on the bottom. So these conversion factors, you could flip them any way you need. In this case, we're starting with moles, so moles is going to end up on the bottom here. So I'm going to write 1 mole on the bottom and then 399.91 grams on top. Okay, and then I'm just going to multiply those two numbers together. So I get 1.223 times 399.91, and I get 489. I should have 4 sig figs. It's always the number they give you that limits your sig fig. So I should have 4. Your molar mass should go 1 more than the number they gave you. That's why I went all the way out to 5. Okay, so I'm going to write 489.1 grams of Fe2 SO4 3. Box your answer. Okay, for part B, how many moles of ammonium ions are in this many grams of ammonium carbonate? So ammonium carbonate, NH4 plus CO3 2 minus. So when I write my formula, I'm going to write NH4 parentheses 2 and then CO3. So that's my formula. So how many moles are in this many grams? So I'm going to write 6.955 grams of NH4. Please don't Google these names and come up the answers. You guys use your skills that you learned in the videos and from reading chapter 2 on how to do this. This is very important and it's rudimentary. It's really basic and fundamental, but I can't emphasize the importance of doing it. So don't just Google this and write the formula. I know that's like the easy way. To me, this is the easy way because it's faster than Google, and that's a like a confidence booster. Don't you want to be faster than Google? That's awesome. The human is faster than a computer. So NH4 2 and then CO3 times. And then now on this one, I have grams, so I want my grams part of the molar mass to be here, and then 1 mole on top. So I just need to go enter this in my trusty molar mass app. Okay, so it was parentheses NH4 close parentheses 2. And see, this is what I mean. So it already knows, it has like a built-in database of common chemicals. So ammonium nitrate, or sorry, ammonium carbonate is right there. So I tap on it, 96.11. So 96.11 goes here, 96.11. Okay, and it looks like it just divide these two. So 6.955 divided by 96.11. And I should have 4 sig figs. I probably should have went to one more decimal, but that's okay. So I should have 4 sig figs here. So 0.07 to 3. So this one does not count. That's not a sig fig. Go back and watch the sig fig video if you don't get why. So that doesn't count. And then a 6 right here. So moles of ammonium carbonate and box my answer. Okay, in the your turn, I have you doing part C and D on this one. Okay, so next slide, we're gonna do a stoichiometry problem on this one, and this is the last example. All right, so on these, usually you have like mass, so you have like a here's your scale, and here's your readout and your sample. So you have like mass of X, and usually you have to change it to moles of X, and then change it to moles of Y, and then change it to uh, here's another scale, mass of Y. So this is of Y mass of X. That's how stoichiometry works. And how do you go from moles of X to moles of Y? Is you use the balanced mole ratio. So you go moles of X equals moles of Y, and you get these numbers from the coefficients in the balanced reaction. Again, all the general chem teachers should be covering this, so I treat this as a rudimentary skill. But I will post, look for in the description, I'm going to post my flowcharts for doing mass to mass and particle conversions. So they don't cover everything we counter in AP, so just a word of caution. Um, but I'm gonna just go ahead and do this problem. Okay, so it says how many moles of N2 are produced by the decomposition of 1.5 moles of sodium azide. So the connection is going to be between this substance and this substance. In my little flowchart, I wrote X and Y here. This is X and this is Y, substance X, substance Y. So this is just from moles to moles. So this problem, we're just going from here to here. This should only be one step in this problem. Okay, if you read carefully, it says how many moles of N2 from this many moles of NaN3. So I have 1.5 moles of NaN3 make sure you write the whole substance. This is part of doing the problem. So in the summer assignment on these, I think it's the very last, it's like 61 to 64 from chapter 3, is make sure you write out your substance, the name of the substance. Otherwise, you'll have like moles and moles, and you won't be able to keep track of which is which. So times, and I want to convert to moles of N2, so I'm going to write 3 moles of N2 that goes in the numerator because I want this unit to cancel. So I'm going to write 2 moles of NaN3 on the bottom so that it cancels with the 1.5 mole. So I write 2 moles of NaN3 on the bottom. So this cancels with this. So you see this whole thing is the unit, even the substance. Okay, so it's 1.5 times 3 divided by 2, and I get 2.25. I should have 3 sig figs because of this number, 3 sig figs here. So my answer should be 2.25 moles of N2. Box my answer. And then part B, this time we're going from mass to mass. So I'm going to erase my scratch work there. So this time we're going from here to here. We're going all the way across. So this is going to take 1, 2, 3 steps. This should take 3 steps to do this. We got to get it to moles first, then mole to mole, and then the mass of the new substance. So we have 10.0 grams of nitrogen gas N2 times. So my first step right here is mass to moles. So I need the molar mass. And then when you go moles to mass at the end, you're going to need the molar mass of the new substance here. So N2, I'm going to write 1 mole of N2 is, and nitrogen is just 14.01. So 1 mole of N2 is 28.02 grams of N2 times. And then I'm going to erase my scratch work from before so I don't get confused. This problem is dealing with N2 and sodium azide again. So it's 3 and 2, my mole ratio. Okay, so I'm going to write 3 moles of N2, which is right here. So that cancels with that. My grams of N2, by the way, cancel. And 2 moles of NaN3 times, draw a line. And now I'm asked to get grams. So I'm actually, if I look at my flow chart, I'm actually right here right now. So I just need to get to grams of sodium azide. So I'm gonna go to my trusty molar mass app and get rid of what I had before, sodium azide N3. Okay, 65.02. So 65.02 grams and 1 mole of sodium azide on the bottom. Notice on the first molar mass step, I started with grams, so I flipped grams on the bottom. And when I finish it, I had moles of the new substance, but I want grams of the new substance. So this time, the molar mass is actually flipped from what you had before. So it depends what you're trying to cancel. The unit is what goes on the denominator in the subsequent step. So moles of NaN3 get canceled with moles of NaN3. Okay, so this one's kind of a fun one to enter in your calculator. And I want to conquer all this calculator stuff, like entering stuff in your calculator. I want to conquer all of that in the summer assignment. So we don't want to waste time this year fumbling on like entering exponents, entering multiple step calculations in one shot. I want to deal with all of this in the summer assignment. So you really should be entering all of this in one shot in your calculator. Okay, so I'm gonna go. Uh, I'm gonna use that. I love this fraction thing. So I'm gonna go 10 times and 10 times 2 times 65 what was it, 65.02. So 65.02. And then on the bottom, I'm trying to remember the problem here. In the bottom, I had 28.02 times 3 in the bottom. So let's go back to my calculator. It should look like this, like that. Okay, and then I hit enter, and then I get my answer. So it should be, let's see, it's the 10 grams that's going to limit your sig figs. So let's go back to the problem. Yeah, it's 10.0. So this was 3 sig figs. So my answer should be 3 sig figs as well. So 15.5 grams of sodium azide, and then box my answer. All right, so just to repeat, your answers, they need to look like this and this. You don't need to show the GCD table and all that, but your solution should clearly show the canceling of units. Okay, so let's go to the next slide, and this is the your turn. So this is the first one, and it's just like the first example that I did earlier. Just do B, C, and D in this one. Okay, so I'm going to go to the next slide. So pause it if you need to write out this problem. Okay, and then these two, these are the next two. So this is actually like the second example. These are just particle conversions. There's no reaction happening here. And then in number 3, this is a stoichiometry. So this is like the last one I did, where your dimensional analysis is using a chemical reaction. So somewhere in A and B, you're gonna do a mole to mole step. All right, so that's the end of the video.